Alright team, this is week 18 of Pure Maths 3 maintenance. The first question is an algebra question where we are looking to find the remainder when we're dividing x cubed minus 2x plus 4 by x minus 1. Now, if we're dividing it by x minus 1, to find the remainder, we could do a long division question, we could do long division, but the easiest way of doing it is going f1, right? If this is a factor, then x will be 1 when we're trying to factorize it or divide it by that. We're going to make x equal to 1. And so when we pop 1 into here, we get 1 cubed, which is 1. Take away 2, which is minus 1, plus 4, which is 3. So the remainder is 3. Now, the next one, we've got to show that this is a factor. So if x plus 1 is a factor, then f minus 1 equals 0 if x plus 1 is a factor. Okay, well, let's do that. 4 into minus 1 cubed minus 1 squared minus 11 times minus 1 minus 6. Now, what does this give us? So we get negative 4 minus 1, negative 5, plus 11, which is positive 6. Take away 6 is 0, and therefore x plus 1 is a factor. Oh, this is nice and easy so far. Now, the next one, we're trying to express y in terms of x with this logarithmic function, where ln y minus ln bracket x plus 1 equals ln x. Now, the first thing is I'm going to use my log rules to write this as ln y over y plus 1 equals ln x. And at this point, I can remove my logs from both sides. And then I'm going to times both sides by y plus 1. So I get y equals xy plus x. Then I will go y minus xy equals x. I will factorize, so y into 1 minus x equals x. And then I can divide both sides by 1 minus x to get y equals x over 1 minus x, and we are done. So that was quite easy, that one also. The next one, oh dear, what have we got here? The angles A and B are such that sine A plus 45 equals 2 square root 2 cosine A minus 1. And then we got 4 sec squared B plus 5 equals 10B. Without using a calculator, find the exact value of this. Oh, wow. This sounds like a pain in the neck. Okay, let's do this. Let's do this pink one first. So the pink one, so this one here, we'll use our addition rules here. So I'll rewrite that first bit as sine A cos 45 plus cos A sine 45 equals the 2 square root 2 of times cos A, and then we can, what can we do here? Okay, in my next line I can gather my like terms, so I go sine A cos 45, and then since I've noticed that I've got a cosine A here and a cosine A here, I'm just going to bring that across to the other side. Use my it says not to use your calculator, but we know what sine 45 is, okay? Or at least we ought to. And then we can subtract that cosine A from the other one. So we will get, what is it going to be? 3 square root 2 over 2 cos A. Now when it says not without using a calculator, you can check, right? They're not going to be like, oh, he must have checked, okay? You should know what sine 45 is, but if you don't, you can still use a calculator, and you're not going to be marked down as long as you're showing you're working like we are here, okay? Now, the next thing is, I also know what 45 is, so I can rewrite that left-hand side as square root 2 over 2 sine A equals 3 square root 2 over 2 cosine A. My next line, I'm going to write tan A, so I'm dividing both sides by the cosine, and then I'm going to go 3 square root 2 over 2 times 2 over square root 2. I can cancel, and so I should get tan A, and I can cancel that, equals 3. Okay, so I've done the pink bit here. Now let's see how we go with this this green bit. Okay, what can we do it? Yeah, we'll do it with this. Okay, so I'm going to immediately change that sec squared b into 4 into 1 plus tan squared b, because that's my identity, plus 5 equals 12 tan b. And then I will expand, so I get 4 plus 4 tan squared b plus 5, and I'm going to probably just bring everything across to this side, equals to 0, and go 4 tan squared b minus 12 tan b plus 9 equals 0. And if I factorize that, that looks to me like 2 tan b minus 3 squared equals 0. So we can say that tan b equals 3 over 2. And now we're on to the last step. So now we have to do this yellow one here, the exact value of tan A minus B. So remember, tan A minus B is equal to, and we've got our identity, our addition rule here. So this is tan A minus tan B all over, and then it's 1 plus tan A tan B. Now, since we know what tan B is and tan A is, we can just substitute all of that in. So we go 3 minus 3 over 2 over 1 plus 3 times 3 over 2. 3 take away 3 over 2 is like 6 take away 3 over 2. So it's just 3 over 2. And then on the bottom we've got 1 plus 9 over 2, which will be 11 over 2. Now, that's the same as 3 over 2 divided by 11 over 2, which is the same as 3 over 2 times 2 over 11. Cancel, cancel. So it should be equal to 3/11 is our exact answer. Well, I hope that makes sense to you all. Now we're moving on to the differentiation question. Oh, really? I'm going to use the quotient rule again. So remember, your quotient rule is when you've got y is equal to u over v, then you've got dy dx is equal to, what is it now? V, it's in the formula sheet, v du dx minus u dv dx over the v squared. Now we can just use this. So if we are to differentiate this one here, du dx would be minus 6 squared x. And if we're to differentiate this one, that's just simply 6 squared x. So let's put it all together. So we've got v. So we've got 1 plus tan x bracket into negative sec squared x minus, and then we've got u, which is bracket 2 minus tan x into positive sec squared x. All over 1 plus tan x all squared. Now all we need to do, we want to find the equation of the tangent to the curve at this particular value for x. So at x equals pi over 4, dy dx is equal to. Now all you need to do at this point is chuck in pi over 4 into this ridiculously ugly formula. I mean, we could simplify it further if we want to. Like, we totally can do that. But I don't actually see the need, because that's not what we're trying to achieve here. So I'm just going to chuck my value of pi over 4 in. And when I do that, I was getting negative 3 over 2. Now, if that's the gradient, all I need now is a y value at x equals 4. Sorry, x equals pi over 4, and y is equal to. Now, when I plug that into the original equation, i.e. this one here, I was getting 1/2. I'll just do a quick check on that to make sure I'm on the right track. 2 minus tan pi over, what the heck, pi over 4 bracket, and then on the bottom we've got 1 plus tan pi over 4. I mean, again, we could probably do this now. Heads, couldn't we? 2 minus tan, oops. What am I doing? 2 minus tan pi over 4 and 1 plus tan pi over 4. I seem to be stuffing it up somewhere along the line. Oh, the reason is, yeah, no, it's good. I foolishly had my calculator in in degrees, so it is, yeah, totally is 1/2, and we could work that out just using the exact values that we should have already learned, which, to be honest, I always forget. Okay. I'll get there. Your memory's not as good when you learn something when you're older. Okay. So now that we've got that, we can use y minus y1 equals m into x minus x1. And what am I doing here? So I'm going to go y minus 1/2 equals, and then I've got my negative 3 over 2 as my gradient, into x minus pi over 4. And we can just rearrange this. So we get negative 3 over 2 x. Then we get positive 3 pi over, what's that, 8 plus 1/2. And we need c to be correct to 3 sig figures. So I just chuck that in the calculator, and I can go y equals negative 3 over 2 x, and 3 pi over 8 plus 1/2 gives me 1.68. And that's it. Now we're doing integration by substitution. So what are we doing? We're substituting. Okay. So we know that square root u equals the square root of 4 minus 3 cos x. We also know that du dx is equal to negative 3 sine x? No, negative 3 sine x, so it should be just 3 sine x. And then we can rearrange that, so du equals 3 sine x dx. And is that going to help me at all? What I could then do is maybe rewrite this sine 2x here using my double angle rule and see what that gives me. So I could go sine 2x is equal to sine x cosine x. Just wonder if that's going to help me. I'll get some points by replacing my limits. X equals 0. Therefore, u would equal, and I just chuck in 4 minus 3 cosine 0. Now, cosine 0 is 1. So 4 take away 3, so that should be 1. And when x is equal to pi over 2, which is our upper value, or our upper limit, what do we get? So we get 4 minus 3 cosine pi over 2. 3 cosine pi over 2 is 0, so we get u is equal to 4 here. So that's going to get me some method marks, even if I don't know what I'm doing for the rest of this. Okay. Now, what can I do next? I guess I'll take stock of where I'm at the moment. So I can do this. I've got my lower limit is 1, my upper limit is 4. And then I can say that I've got square root u on the bottom. Dx, and then 9 sine 2x. Now, I'm thinking, see, I've got a 3 sine x here with this du. Whoops, what happened there? So I think I'm on the right track with this. So what I'm going to do at this point is I am going to take that sine 2x and replace it with 9. So it's 9 sine 2x, so it'll be 9 sine x. Wait, sorry. 18, won't it? Oh, I've made a mistake there. That should be 18. So it'll be 18 sine x cosine x over square root u dx. Now, given that we could potentially rewrite dx, so dx could be equal to 1/3, 1 over 3 sine x du. We could then replace this with what's 1/3 of 18 is 6, so 6 cosine x over square root u du. Okay, because that du is du times 1/3 sine x is going to get rid of the dx and the sine x and reduce that 18 to 6. Now, 6 cosine x. So what we can do, I'm looking at this here and I'm thinking this can help us at this point. So I'll go 2u equals 8 minus 6 cosine x. Therefore 6 cosine x equals here. 8 minus 2u. And now I think we are just about there. So we can replace that 6 cosine x with 8 minus 2u. So here we go. We've got limits 4 and 1. 8 minus 2u all over square root u du. And I think we're done. Now, all we have to do is, we could simplify it, couldn't we? So we could say that's like 8 over, so that would be 8u to the negative 1/2 minus 2u to the half du. Now, when we come to to integrate this, we should get 16u to the half minus, now that would be 2 divided by, so it should be 4/3. That's right, 4/3 times u to the 3/2. Just check by differentiating again. So we get 12 over 6, which is 2. Yeah, so that's good. And then limits 1 and 4. Now we just applied those limits. And so the first one, we get 16 times 2, 32. And, 4, 2, 8. Okay, I'll just use the calculator. What is that? So 16 times 2 minus 4 over 3 times 4 to the 3/2. 64 over 3 is our first one. And the second one is just going to be 16 minus 4 over 3. So 4 over 3. And so this should give us 20 over 3. And that's it. So a little bit hard to get started on that one, but remember, like I said, do these steps here. As I said in class, do those steps. Do these kinds of steps, okay? And you're going to get some method marks, and you might just find your way as you go as well. Now we're doing some partial fractions nonsense here. Okay, so I think we want to write it out as a over x minus 1 plus b over x plus 1 plus c over x plus 2. So we can rewrite this as a bracket x plus 1 bracket x plus 2 plus b bracket x minus 1 bracket x plus 2 plus c into x minus 1 into x plus 1. And this should all be equal to 3x squared plus 4x minus 1. Now I'm going to say let x equal minus 1, and this will get rid of a and c, and it will leave us with negative 2b equals, now plug in the minus 1 into the right hand side, minus 1, so 3, I think negative 2. So b equals to negative 1. And then we're going to go let x equal minus 2. Now this is going to rule out a and b, so we'll be left with c. So negative 2 minus 1, which is negative 3, negative 3 minus 1. So I think it's 3c equals, now we put the minus 2 into the other side, so we get 3 times negative 2, 12. 12 minus 8, which is 4, minus 3, which is 3. So c is equal to 1. And then I think I'm just going to let x equal 1. This is nice and easy. And this will get rid of everything except a. So we get 6a equals, and then we just look at this side here. 3 times 1, 3, 7, 6. Okay, so we get a equals to 1. And that was it. That's all we have to do. So it's going to be 1 over x minus 1 plus 1 over x plus 1. What did we say c was? Oh, how boring. Plus 1 over x plus 2. And that's it. Alrighty, last question. This is a bit easier than last week, I think. We've got these points. They're three vertices of a parallelogram, A, B, C, D. Okay, so here's A, B, C. So D's over here. So this is a parallelogram, right? Now, find the vector equations for the sides AB, BC, and AD. Okay. AB. So let's find AB first. To get from A to B, it's going to be equal to, you take away A from B. So it'll be 2 minus 4, 3 minus 5, 4 minus 10. So this gives us minus 2, minus 2, minus 6, I guess. Or minus 1, minus 1, minus 3. Now, if we're doing a vector equation for the side AB, I guess we could do, do they want us a line equation? So if it's a line equation, we could start at A. 4, 5, 10 plus mu minus 1, minus 1, minus 3. So that would be equation AB. Let's consider BC. So that's AB. BC. Now, going from B to C, so we're going to take away B from C. So it'll be 1 minus 2, 2 minus 3, minus 1 minus 4. That's a 4. Looks pretty scrappy. Let's see if I can fix it up. And this gives us negative 1, negative 1, negative 5. And so the vector equation for BC is R equals, and we'll start at B. So B gives us 2, 3, 4. Plus, and then maybe lambda, minus 1, minus 1, minus 5. And then last of all, AD. Now AD, because BC and AD are parallel to each other, we're going to use this bit again. We just need to start with A instead of D. So this line is going to be, starting with A, should be 4, 5, 10, plus, and then, I don't know, some Greek letter. We'll just use lambda again. Minus 1, minus 1, minus 5, and that would be the vector equation for that one. So there we go. Hope that's been helpful to you. Hope you're feeling a little bit more comfortable with these. Let me know if I've made any errors, which is entirely possible, and have a great day.